I broke my camera tripod again. It fell over and shattered a star knob stud. Fortunately, the camera was not attached. I have plenty of star knobs in the shop, but none of them fit, so now I need to make a new one. If you're anything like me, you have lots of bolts in your shop. I had one that fit perfectly, but I needed to 3D print the plastic for the knob. In this video, I'll show you how to do it. It cost me, I think, 13 cents or something like that. In a previous video, I showed you how to make star knobs like these using Fusion 360 and a 3D printer. I'm going to expand on the use of Fusion, specifically the use of parameters. Parameters is a great tool. It allows you to make changes to your design in a matter of seconds. In fact, every time I start a new design, one of the first things I do is setting up the first few parameters and naming them. The key to good design is staying organized, and the best way to do that is to get the project started right. My background is in aviation, so using checklists come natural to me. Of course, I also used one for Fusion. I posted a copy of my checklist in the 3D sites in case you find it helpful. You can also just pause this video and take a screenshot. And while you're doing that, why don't you take the time to subscribe to my channel and like this video. Okay, let's get started. This project is so simple, it only requires 2 or 3 parameters, so it's absolutely perfect for demonstration purposes without boring you to death with a lengthy video. So after opening Fusion, step 1 is saving and naming the file. Hit Control S, or if you use a Mac, I think it's Command S. I'll call this M8 male star knob. We're using millimeters, so we can skip step 2. Okay, create and name a new component. I have it set as a shortcut key as N. We'll call it knob. Before I type in the parameters, I need to measure the bolt that I found in my shop. An old bolt I just had to clean up with a wire brush. It's going to work great for this project. Okay, back to Fusion. We will open parameters. We'll resize that window a little bit. And we're ready to enter our first parameter. We'll call it hex radius, 6 millimeters, which is half of the 12 millimeters for the hex bolt, the head. Next, we need a hole for the bolt, 8 millimeters. We'll call it hole diameter. And we'll set the bolt 7 millimeters into the plastic. Let's call that a hole depth. Following the checklist, next we'll set the view. I'm going to use top view here, and we'll save the file. We're ready to design. Just like last time, let's make it easy and look at McMaster's, what they have. Type in knob. Well, let's widen the window a little bit so we can see what we're doing. Type in knob, and we'll find a metric knob, the right size. We'll use a 4-wing. And let's just have a non-hold design. There we go. There's one. Import it as a 3D step. Bingo, here's our knob. We just need to modify it a little bit. Very easy to do. Click on Home. Now click C for circle and select the top of the knob as the surface. Set the radius, the diameter, to the whole diameter we put in our parameters. Click E for extrude. Select that new circle. Rotate the knob a little bit so you can see what you're doing, and then drag it all the way through. Click OK. Click top again. Now you have a through hole. Next we need to make room for the bolt head. Click Create Sketch. Select the top of the knob as the surface. And select the polygon, the first one. The measurement here is the hex radius that we selected in parameters. It's automatically set for a default of 6 sides, so we don't have to change that. Click E for extrude. Rotate the knob a little bit. Now notice this is a negative extrude, so we need to put minus hex depth. Now I forgot to change it to a cut, so let's go back in and edit that feature, and just so instead of a new body, select a cut. Here we go. Let's put a chamfer on that hex shape. Go back to parameters, add chamfer, and we'll make it 0.5 millimeter. Because we have parameters set, we can always change it very quickly. Select the chamfer tool. Select all 6 edges of the hex and type in chamfer. Click OK, and here we go. We are done and ready to print, but let me first show you the power of parameters. Let's open parameters, and let's say you found that the bolt head was actually 14 millimeters. Simply click that setting and change to 7 and see what happens. Instantly it changes. Let's try it changing the chamfer to 1 millimeter. Bingo, instant. Now let's just go back to this and save the file, and we're ready to print and assemble this object. Now export the file to a 3MF file so you can 3D print it. Open the file folder and go ahead and print. Once you're printed, it's time for assembly. You can use epoxy glue to insert the bolt, but due to plastic shrinkage, the 12 millimeter size for the hex bolt was actually perfect. It fit very snug. In fact, it needs to be heat treated to be inserted. That will hold it in place. I'm using here a heat gun, and I put the bolt in the drill press so we get evenly dispersed heat. Perfect. I realize this video got a bit long. The thing is though, if you organize your designs and you use parameters, you can go right in and modify it to your liking later on. Next time you probably need a different size bolt, and it's so easy to modify the design you already made. I hope this video was of use to you. Please consider subscribing to my channel, and see you in the next video.